Sit down.
Okay, welcome everybody. I can see, yeah, okay. I'll try to be as interactive as possible because we are like less number. I think I'm sure we can be interactive here. You can all see my screen, right?
Yes, ma'am.
Yeah, ma'am.
Awesome, awesome. Okay. I can see a lot of Indians here. So when I say Kolam, I know many of you understand what Kolam is.
Kolam, my mother and my grandmother do it every day.
Yeah, right. So today what we are going to do is we are going to try to understand what is Kolam and a little bit about its history. And then we were going to dig into how we can use columns to learn mathematics. For many people in our group, they still might not know what is Kolam. Kolam is a freehand drawing on drawn on the floors in a southern state of India.
In the house next to the main door.
Yes. So there are curved line patterns drawn at the entrance of a household in Tamil Nadu. I say Tamil Nadu because the term kolam is widely used in Tamil Nadu. But this kolam has different names around India actually. And you might be knowing about the term Rangoli, or some people call it Muggu in Andhra Pradesh. In other parts of India also, the same tradition is used, but in different names. Kolam is very unique. I come from South India. I come from Chennai. So I know it's very unique to my culture. I grew up drawing columns in front of my household. And then I did a little research on columns too. So that helped me to, connect things and make an approach to early learning of math. With this background, I would like to take you to the history of Kolam. Um, Earliest history or first reference of Kolam was seen in or whatever earliest dated, I would say, was seen in Tamil literary work in Madurai Meenakshi Amman Kuram. Madurai is again. Yes, Krishna?
I went to the Madurai Meenakshi Amman temple.
Oh, okay. Nice. So this is the history and the written content of where Kolam is or how it came was seen in a 16th century work in Madurai Meenakshi Amman Kuram. But the practice of drawing kolam date back or written history again says it's around 600 years old. But if we dig in deeper about columns, the geometric designs which you see in columns are actually found in ancient temple carvings in India, which are more than 1,000 years old. So for history, maybe written, it says around 600 years, but as you see in this carving, this temple is located somewhere in Rajasthan. And this temple is more than 1,300 years old. And the drawing you see is similar to the columns we draw in southern India. So the drawings are much prevalent, the carvings are much prevalent, much before 600 years old. Kolam in the current generation is actually took a way of an art form, not just like drawings in front of the household, but it went to finding its place on artworks around in mud pottery, in wall frames around the world actually. And these drawings, these intricate patterns you see are available all around. I mean, many places apart from just in front of the household, and then even in jewelry too, or clothing. But where are we getting at? Actually, French brand Isimiaki launched a fragrance inspired by this art in 2020. So it's getting to places. It's traveling a lot now. But Kolam, as we know, why I'm talking about types of columns, we are going to try to distinguish it so that it's easier for us to understand the patterns and make a connection of how we can link it to the geometry we are going to learn today. So this types of columns, according to me, which makes it simpler to understand or decipher and draw them. Okay, so these are the three kinds of columns. One is called the padi column, one is called the pulli column, and one is called the sikku column. I would explain it deeper so you understand. What is a padi column? Padi column is again a freehand drawing. So the geometric shapes, usually a square, if you see in this, a square is taken or drawn, and then it is developed with more geometric designs like a triangle and a rectangle, and then it's still developed. So these are freehand drawings again. They don't have any identifiers to draw. They're drawn freehand on the floor. But these are geometric patterns. So this column, this very traditional padi column here you see is actually, it starts from a square and then a triangle and a rectangle, and it can be developed depending on the artist. Every household has an artist here. And if you see this starts from a star. It's an 8-pointed star, and then it gets developed into more triangles and semicircles. And then this starts from a plus sign, if you see here. And then parallel lines are drawn to connect it. So this is called the padi column. It's completely freehand, and mostly geometric patterns are used here. Now, when it comes to pulli column, see, we like to simplify things, right? So pulli column is like simplification of a padi column. If you are not a freehand artist, what would you do? Okay, so you need guides to do it. So we will place dots. So this is like simple joining the dots game on the floor using a chalk, or usually they use rice flour. But current day we can use chalk or anything. It's simple joining the dots game, but make intricate patterns out of it. So now you don't need to do geometric patterns. You can do much deeper patterns, like this is called cotton floret. So joining the dots, and now again the variation here is the joining the dots is either in a square or in a what do you call it? It's in a hexagon shape. So the dots are placed one below the other here when it comes to a square pattern, and then if in the hexagon pattern the dots are placed one in between the other, so it comes to a triangular shape. So it depends on how you're placing the dots, your drawing would come up with. So that is a pulli column. Pulli means dots. So we use the help of dots to make our column drawing, to make our patterns. And then the sikku column. This is actually the most intricate one you would see. If you see now, it's not merely joining the dots. We are trying to escape the dots actually, or intertwine the dots to make these patterns. So these dots, either the intertwining, kambi means it's actually a line or a wire. So you're trying to, every dot placed is intertwined and and this pattern is made. So here you see the trick part of this column is either the lines are many, or sometimes it's just one line which will intertwine all the dots placed on the floor. So if you see this column here on the left and this column here on the right look similar, but there is one difference. Can you try to identify the difference? The one on the left here and the one on the right here, both are done with four.
The one on the left, it's one line throughout, and the one on the right, it's like the squares, like each of them are like separate lines.
Yeah, you got it, Muskan. So you see the difference. So that's the trick part of it. It's again about how we can create our lines. It's completely in our hands to create these columns. This column is very popularly known as Krishna's anklet, actually. So you can either draw it just one line or one kambi or many kambi. So it's called a single kambi column or multi kambi column, or what you say. So again, these are the three types of columns, and what we can learn from them mathematically is immense. The research works have been done on these. What we are going to learn today is one small thing about symmetry. You all know what is symmetry, right? Do you?
Yes.
Yes. What is symmetry? In geometry, an object exhibits symmetry if it looks the same after a transformation, such as a reflection or a rotation. This is the definition. Okay. So what we are looking for is transformation of that object after an effect on it, like a reflection or a rotation. Okay. Now, images, shapes, or drawings, which can be divided into two identical halves. Okay, are generally called to be symmetrical. Okay, like if you see this letter A, can I say that this image, okay, don't see it as A. If you see it as an image, does it reflect symmetry? Does it?
Yes.
Yes. Okay. So if I draw a line here in the middle, okay, and then see the two halves, you see they are identical, right? So now this image or the letter A, we can say exhibits symmetry. The kind of symmetry is called mirror symmetry or reflection symmetry. Okay, and then the line where you can draw a line and see there are two identical halves or many more identical halves. This line is called the line of symmetry. Okay, now we are trying to learn the geometrical terms attached to symmetry. Okay, so now if you see this shape, does it exhibit symmetry?
No.
No. Think again. Can you
Yes.
draw a line somewhere in between or like this and see whether they are two halves which are identical? Yeah, I have a thumbs up from Muskan. Yes, it does. And if you see, you draw a line in between, the two hearts, two sides of the hearts are identical. You can fold them into and then see they are identical. So this also exhibits symmetry, and you can draw a line. And so this line is called the line of symmetry for this image. Now there are many images which are not symmetrical. So they are called asymmetrical, like the letter G. My name is G, so I took my letter G there. And I try to draw a line wherever, here, here, here. I'm not symmetrical. Sorry. So, or this cloud, the shape. You will not be able to draw any line there and try to fold it. Now we are talking about mirror symmetry, okay, guys? So we are trying to fold that image and see whether that exhibits symmetry. So these two images do not exhibit symmetry or mirror symmetry, okay? Now coming back to our columns, how can we learn or see whether there are symmetry in these images? Forgetting the colors on that, in this column, you see this beautiful pattern. Can you draw any line of symmetry in this column? Yes, Muskan? Anybody else want to answer? Unmute yourself. It's okay. We are just a small group. I think we can interact with each other. Yeah.
Yes, there can be a line symmetry.
Yeah, it's called mirror symmetry. So we can draw a line straight there and see that you can draw a line and then it's symmetrical. So we can fold it like this and it's the same. Forget the colors, okay? We are not looking at the colors currently. And then I can also draw another line here and then fold it like that and see it is symmetrical, right? Wait, but can I draw a line here and fold it and see if it is symmetrical? Yeah?
Yes.
Yeah. And then one more. Cool, right? So when we see these patterns, you see, and then now you see how many lines of symmetry this pattern has, right? So this, of course, this column is symmetrical. Now we know it has mirror symmetry. We know that. And then it has 4 lines of symmetry in its pattern, right? Let's see this column. Again, forget the colors. Can you draw lines of symmetry here?
Yes.
Yes. How many lines of symmetry do you think you can draw? Forget the colors, okay?
4 lines.
4 lines again. So you have one here, you have one here, Yeah, you can do that and try to fold, right? And this one too. So again, this column is another symmetrical column. What I want you to do is, if you have a paper and pen in front of you, okay, pick up and then try to draw something, a column. You may think of a symmetrical column, but try to draw. What I would like to give you is just 6 and 6 dots on your paper. If you can do that, I'll give you 2 minutes time to just join the dots and make any pattern. Are you trying that? Give me a thumbs up if you're trying it. I'll be excited to see your work. Yay, thank you, Avni. Muskan, Krishna. Adya, thank you. Gokul, Revti, Ivan. Are you trying to draw your column? Wow, Avni, you finished? Not yet? Okay.
I'm done.
You're done. Cool. Krishna, nice. Did you place the dots? Did you join the dots already? I would like to see your work if you're done. This is by sample. I just joined the dots with some triangles and squares and some straight lines to make it symmetrical. But it's up to you how you want to draw. This other one, which I made. Oh, beautiful. Lovely, Revti.
Thank you.
Oh, nice, Muskan. Okay, I'm still trying to navigate between the screens. Okay, if you have done drawing your column, okay, what can we understand? They are like till now what I was talking about the symmetry. It's called mirror symmetry or reflection symmetry. Okay, but wait, we can learn more about symmetry with these columns actually. Okay, so reflection symmetry, as we learned currently, was that we will be able to draw a line and then it can be as a reflection, a mirror image of the same. You know, we might exhibit symmetry, like if we draw a line perpendicularly, our left side and the right side might be similar, right? So we also, humans also exhibit symmetry. Likewise, the columns which we are drawing, you may be able to draw lines to see if you have a mirror symmetry or reflection symmetry. Like this column here, I can make 2 lines and say that it's symmetrical. Now wait, there is another kind of symmetry which I want you to learn today. Now this kind of symmetry is called rotational symmetry. Now remember when I said symmetry is something which the image looks the same after an effect on it. Okay, the first one we said the effect was mirror or reflection. Okay, now this effect is if you rotate the image. Okay, so the shape looks the same after a rotation. Okay, so this is called rotational symmetry. Now, how many times it matches as we go around? Oh, wow. Oh, wait. It's called the order of rotation. Okay. Now, if you see, for example, I'm going to take my column with triangles and squares and I try to rotate it. Now, I know it has mirror symmetry. Okay. But does it have rotational symmetry? So if I try to rotate it like this, and it looks the same. And every time I rotate it, it looks the same. So I was able to turn it 4 times from here to here. And then every time I turned it, my image was still the same. Now this is called rotational symmetry, and the order of rotation is 4 because I was able to turn it 4 times to get the same image. Okay, let's try this star. Do you think it has rotational symmetry?
Yes.
Yes. Will you be able to rotate it and find out how many is the order of rotation? What is the order of rotation? So it is 5-point star.
Because it has 5.
Try to turn. I can turn it once. I can turn it twice. I can turn it 3 times, 4, and 5. So when I turn it 5 times, it still makes the same 5-pointed star. So of course, this shape has rotational symmetry and the order of rotation is 5. Correct? Now let's go back to another column. Now this is like a really tricky column. Now this has mirror symmetry. Do you think it has mirror symmetry?
Yes.
Yes, I can fold it, right? And I can see there is a line of symmetry here. There is a line of symmetry here, and there is a line of symmetry here. Now, can you see if it has rotational symmetry? Can you turn it around and see if you can find an order of rotation?
It has a rotation symmetry.
It has a rotational symmetry. Yeah, that's why I showed it here, right? So what is the order of rotation? How many times you can turn it to get the same image? Right? So if you see, I turned it 6 times, and every time I turned it, I have the same image. See, that's 1, that's 2, that's 3, 4, 5, and 6. So this column also has rotational symmetry, and the order of rotation is 6. Correct? Now, in your column, what you have drawn, can you find mirror symmetry and rotational symmetry? Can you check? I would like to have 1 or 2 volunteers here. Can you show me your columns and try to see whether you have mirror symmetry or you have both mirror symmetry and rotational symmetry?
Mine has rotational symmetry and symmetrical symmetry.
That symmetrical symmetry is called mirror symmetry or reflection symmetry. Okay? Yeah. How about Solange? How do I call you?
Solange. Hi.
Solange. Hi.
And this is Kaylee.
Hi, Gaily. So did you draw your column?
Yes.
Yes. Did you find mirror symmetry or reflection symmetry?
I found symmetry.
You found symmetry? And how about rotational symmetry? Were you able to rotate it and see whether it has rotational symmetry? Beautiful, Muskan. Anybody, any other volunteers? Avni?
There's symmetry at the end.
No.
No.
Mine is also rotational symmetry and reflection symmetry.
Awesome, awesome. So many times when we join the dots and do the lines, our mind automatically wants to make it symmetrical. Okay, so that is, mostly you will see a reflection symmetry there. But what we miss is especially when we draw the columns in front yards, we actually have to move around because they are huge columns. So when you move around, the rotational symmetry also comes into its presence actually. So now I'm going to show you some Sikh columns here, okay? And try to identify the symmetry and try to distinguish between the mirror symmetry and rotational symmetry here, okay? So now this Sikh column, the finding mirror symmetry is pretty easy, right? So you try to draw a line and try to fold the image mentally.
I have 4 symmetries.
Yeah, it has 4 lines of symmetry, right? Now, does it have rotational symmetry?
No, ma'am.
Do you think so? Okay, I remove the lines. Now try to rotate it. Okay, now I'm going to rotate it with my computer. See, if I rotate it once, it comes to the same image there. And I'm not going it all the way around, I'm just going 90 degrees. So again, I rotate it to another 90 degrees. It comes to the same image. Now one more time, I rotate it to 90 degrees. It comes to the same image. And fourth time, it comes to the same image. So of course, this column has rotational symmetry also, and the order of rotation is now 4, right? I was able to turn it 4 times. Now I want to show you another column here. Do you think it has reflection symmetry? Yeah, okay. And how many lines of reflection? What do you think? Can I draw a line here and I can fold it? Right?
Yes.
Yeah, I can draw a line here also and I can fold it. So this has 2 lines of symmetry in reflection. Now, what is the order of rotation? I definitely say it has rotational symmetry, but as you see, most symmetrical images may have reflection symmetry and may have the same order of symmetry when it comes to rotational symmetry, but it may
It
not.
has rotational symmetry.
It has rotational symmetry, and what do you think is the order of rotation?
4.
4? Any other guesses?
3.
3? One more guess.
And 5.
5?
Yeah, ma'am.
Okay,
2.
let me.
2.
Okay, who has said 2?
4.
2 is the
4.
correct answer. You see, I have to flip all the way down to 180 degrees to get the same image again. So that is 1 order of rotation, and I have to flip again 360 degrees to get the same image again. So that is 2 order of rotation. So this has rotational symmetry, but the order of rotation is 2. We have 2 lines of symmetry, reflection symmetry, and 2 order of rotation, rotational symmetry. Now, if you see this image, it has reflection symmetry. So I drew a line there. I can fold it. Only 1. Okay. But does it have rotational symmetry? Can we turn and see to any angle to get?
No.
No? You're confident?
Yes.
Yes. Who's that, Ms.Gowri?
Yeah.
Okay, actually you are right. You did try out this, right? So if you see, I have to turn this, and whichever angle I turn till I come back to the whole first position, I don't see any symmetry in the image, which means this does not have rotational symmetry, right? This column. So any image, if you turn and see and it comes back to the image only after 360 degrees, then there is no order of rotation, okay? Or there is no rotational symmetry like. So there is no rotational symmetry. So the order of rotation here is 0, okay? Now let's go to this. I say this doesn't have any mirror symmetry or reflection symmetry. Do you agree?
Man, there is no symmetry.
There's no symmetry. Do you agree?
There is no symmetry.
There is no symmetry, right? Symmetry in the sense, what symmetry are we talking? We're talking about
Reflection symmetry.
symmetry, right? But
It has rotational symmetry.
it has rotational symmetry
4 times.
4 times. Wow.
Yeah.
Everybody agree with that? Everybody agree with Muskan? Or you want to try? You want me to turn the images for you?
Yes.
Yeah, that's the fun part of it. When you see a column, this column actually feels symmetrical, right? Though you try to fold it in any manner, if I want to fold it here, these curved lines do not match somewhere here. So we know that this doesn't have reflection symmetry. But then when I turn it around once, you see it's the same image again. So I went 90 degrees and it came back to the same image. I go another 90 degrees. It comes back to the same image. Again and again. So of course, this has reflection symmetry. Oh, sorry, rotational symmetry, right? It does not have reflection symmetry, but this column exhibits rotational symmetry and the order of rotation is 4, right? So now you see, usually when you see an image, you automatically think it exhibits reflection symmetry. So it might have the same rotational symmetry. But again, these columns give us an example of how they might be reflection symmetry, but not rotational symmetry. And all the lines of symmetry is not equal to the order of rotation. Okay, so that is what we learned today. A very simple thing. Using these columns, we try to understand what is symmetry, right? And we also learned there are two kinds of symmetries we learned actually. And we also learned that columns, we can use columns to learn about symmetry. And then we knew what is reflection symmetry or mirror symmetry, right? And then we learned that reflection symmetry has something called lines of symmetry. And we also know something called rotational symmetry exists, not just reflection symmetry. When we rotate an image, it comes back to the same image at different angles, actually. So we knew what is the order of rotation, which means how many times when we rotate that image to get back the same image, right? So, and that is called the order of rotation, right? So what I would like to conclude as is the columns we can use. Of course, we had fun with drawing, right? We can understand culture. We learned what traditionally South Indians do in front of their household. We learned math, of course, okay? This is what we were trying to learn today. But we also had fun, right? With art, how we can connect math and art here. And then we also explore our creativity. I'm really happy to have you all here and learn a new way of joining the dots, make columns, and then have fun. It's break time here, summertime for us, and it would be same for most schools across the world. And I would encourage you to place those dots in your notebook when you're home. Try to connect them and learn more about symmetry and rotation. Do you have any questions?
No questions, I guess.